Mars, the red planet. That glowing red dot in the night sky isn't just a planet. It might just be humanity's future home. For centuries, this mysterious world has captured our imagination, from ancient myths and Oz to modern science and the dream of colonization. But could there really be life on Mars? If we can go there, can we actually stay there? Mysterious ice caps near the poles, massive canyons buried beneath the dust storms, traces of water beneath the surface, and even hints of ancient life. In this video, we're going beyond everything you thought you knew about Mars. We'll dive into the planet's secrets, its discoveries, and why it might be so crucial for the future of humanity. So buckle up, because our next stop is Mars. But before we begin, don't forget to subscribe to support the channel. Like the video so it can reach more curious minds. And as always, drop a comment to share your thoughts and join the science discussion down below. Mars, also known as the red planet, is the fourth planet in our solar system and one of the few planets visible to the naked eye in the night sky. Like the first three planets we've previously covered, Mars is a rocky terrestrial planet. When Mars is at its closest approach to Earth, the distance between us can shrink to about 56 million kilometers. At its farthest, that distance can stretch to 400 million kilometers, a truly massive difference. According to scientists, in theory, the points at which planets are closest and farthest from each other correspond to their perihelion, closest to the sun, and aphelion, farthest from the sun. However, throughout all of human history and Mars recorded observations, this alignment has never perfectly occurred. As with many other planets we've explored in past documentaries, we don't know who exactly discovered Mars, simply because it is easily visible to the naked eye, suggesting it was discovered in ancient times. The earliest known records of Mars date back around 4,000 years. But we do know who first observed Mars through a telescope. As many of you might guess, it was Galileo Galilei, who made this observation in 1610 using a primitive telescope. Like many planets, Mars gets its name from Roman mythology. Mars was the god of war, and this name seemed fitting for the red planet, as ancient Romans associated its color with blood. The red color of Mars actually comes from iron oxide, rust, on its surface. Mars likely began forming around 4.6 billion years ago, shortly after the solar system started to stabilize. Like many planets, Mars was shaped by solar winds, which blew away lighter elements from its vicinity, leaving behind heavier materials. Over time, these materials were pulled together by gravity, eventually forming the spinning planet we now know as Mars. Due to certain features it once may have had, Mars is considered one of the best candidates for future human colonization. Many space agencies and scientists are currently working on missions and research to make this a reality. If humans are ever to settle on Mars, there are several important factors to consider. Its distance from the sun to avoid extreme heat or cold, whether it's large enough to support a significant population, and how its mass and gravity might affect human life. The red planet, Mars, is located approximately 228 million kilometers from the sun. Relatively speaking, this is a decent distance for a planet to avoid extreme heat. Its mass is about 6.42 to 123 kilograms, making it roughly 10 times lighter than Earth. Mars also has a diameter of 6,691 kilometers, which is about half the size of Earth. Our planet has a diameter of approximately 12,750 kilometers. In terms of size, Mars ranks 7th among the 8 planets in our solar system. So yes, it's considered relatively small. However, if we exclude gas giants from the list, Mars would rise to become the third largest rocky planet. In short, Mars is larger than Mercury but smaller than Venus. Its volume is around 1.6 to 1011 cubic kilometers. Earth far surpasses Mars in terms of mass, as Mars has only about 15% of Earth's total mass. Looking at these numbers, Mars may not seem large enough to host a vast number of people or life forms. But don't lose hope just yet. We haven't even mentioned the good parts. Mars has a surface area of 144,371,391 square kilometers, which is about 28% of Earth's surface area. That might seem small at first glance, but there's something important to consider. About 70% of Earth is covered in water. If we disregard the oceans and focus solely on landmass, Mars and Earth actually have nearly equal amounts of land available for habitation. So there's no need to worry about surface area too much. One of the most crucial needs for human survival is water, and without it, long-term life on Mars would be impossible. Therefore, when we eventually settle on Mars, some surface area will inevitably need to be dedicated to finding and storing water, which may slightly reduce habitable land, but this won't pose a major problem. Also, while Earth can sometimes feel overcrowded, it's important to remember that there are vast regions on Earth with no human presence or settlements at all. If we use Mars's land area efficiently, it could comfortably accommodate a population similar to today's Earth. Finally, Mars is surprisingly dense for its size. With a density of about 3,833 kg/cm3, Mars ranks as the fourth most dense planet in the solar system. Mars' orbital characteristics are perhaps the most similar to Earth's. For instance, one day on Mars lasts 24.6 hours, which is almost identical to a day on Earth. Mars completes one full orbit around the sun in 687 Earth days. Another similarity lies in the axial tilt. Mars has a tilt of approximately 25 degrees relative to the orbital plane of the sun, while Earth has a tilt of about 23.6 degrees. And as mentioned, the greatest similarities between Mars and Earth lie in their orbital movements. Mars, like Earth, is made up of 3 internal layers. These are primarily composed of iron, nickel, and mostly sulfur, although its core also includes lighter elements. Above the core is a rocky mantle, and the outermost layer is a crust composed of iron, magnesium, aluminum, calcium, and potassium. The diameter of Mars's core is estimated to be between 3,580 and 3,000 2,740 kilometers, making it almost half the size of Earth's core. In terms of mass, Mars' core accounts for only about 24% of Earth's core mass, which highlights how small Mars really is compared to our planet. Research indicates that Mars' core has a density of about 3.93 GeH3, and its temperature exceeds 1,300 Kelvin. Mars' atmosphere is composed of approximately 95% carbon dioxide, 2.8% molecular nitrogen, 1.6% argon, along with traces of water vapor, oxygen, carbon monoxide, methane, and other gases, and also a significant amount of dust particles. This dust and gas composition is what gives the Martian sky its distinctive red hue. Mars' surface is rocky and features numerous valleys, craters, volcanoes, and dry lake beds. Yes, you heard that right, dry lake beds, which scientists believe were once filled with water. Additionally, unlike Earth, Mars does not have an ozone layer. As a result, meteoroids entering its atmosphere do not burn up as they do on Earth. They hit the surface directly, which is why Mars has so many impact craters on its surface. Another famous feature of Mars is that it hosts the largest volcano and the tallest mountain in the solar system. Many of you probably know this mountain by the name Olympus Mons. It is so tall that it is about 3 times the height of Mount Everest, which is Earth's highest peak at 8,848 meters. When it comes to atmosphere, Mars unfortunately falls far behind our planet. Mars' atmosphere is only about 10 to 25% the density of Earth's atmosphere. Due to this thin atmosphere, there is a significant temperature difference between day and night on Mars. This extreme temperature variation causes very little or almost no precipitation like rain or snow. This lack of climate events is the main reason behind Mars's dry and barren appearance. The most common natural phenomena we observe on Mars are dust storms. These storms mainly occur in the southern hemisphere during the spring and summer seasons. These dust storms can grow to such massive sizes that a storm that starts in one location can eventually cover the entire planet. NASA's Opportunity rover encountered a relatively smaller dust storm in 2018, which caused severe damage and rendered the rover inoperable, forcing an early end to its mission. Just imagine the disasters we could face if caught in the middle of a massive dust storm. Besides dust storms, gas particles formed in carbon dioxide clouds are lifted by winds and turn into ice particles. As these ice particles accumulate, they tend to circle around volcanoes. When the Phoenix lander touched down at 68 degrees north latitude, it discovered carbon dioxide snow falling from clouds. But interestingly, the snow disappeared before reaching the surface. Some discoveries on Mars have shown that this dry planet wasn't always so barren. It once had an atmosphere and weather phenomena similar to Earth's. Thanks to advancing technology, there's hope that some of these lost features could be restored in the future. The red planet Mars has 2 small moons named Phobos and Deimos. The first of these moons, Deimos, was discovered on August 12, 1810. It was named Deimos shortly after its discovery. The astronomer who discovered the first moon, Asaph Hall, found the second moon, Phobos, just 6 days later on August 18, 1877. We call these moons small because compared to the size ratio between Earth and its moon, or other planets and their moons, they are indeed tiny. Unlike our moon or many other moons, these two are not spherical, but have irregular, pebble-like shapes. Phobos orbits very close to Mars, only about 6,000 kilometers above the planet's surface. No other moon in the solar system or around other planets orbits this close to its planet. Phobos is unique in that regard. Its diameter is just 22 kilometers, making it about 150 times smaller than our moon, which has a diameter of about 3,500 kilometers. However, Phobos is larger than its sibling moon, Deimos. Phobos is slowly spiraling closer to Mars every day. Deimos, on the other hand, is much smaller, with a diameter of just 12.4 kilometers, and is gradually moving away from Mars. Eventually, millions of years from now, Deimos will completely break free from its orbit and drift through space until it crashes into something. Another curious question about Mars is whether it ever had or currently has rings. As you know, some planets in our solar system have rings, Saturn being the most famous example. Scientists have speculated in the past that Mars might have had rings. Although there isn't much detailed research, it's likely that Mars once had a ring formed by debris trapped by its gravity. Currently, Mars has no rings. However, some scientists predict that in 10 to 50 million years, a new ring could form around Mars if Phobos breaks apart. If humanity still exists by then, those who witness this cosmic spectacle will be incredibly lucky. The red planet, Mars. For centuries, it has fascinated humanity, a lonely world glowing bright red in the night sky. We no longer only look at it through telescopes. Our robots roam its soil, breathe its atmosphere, and unravel its mysteries one by one. But perhaps the biggest question about Mars remains unanswered. Will we only set foot there, or will we build a new life? Maybe our generation will take the first step. Maybe one day our children will watch the sunrise on Mars and see Earth shining like a star in the sky. The journey to Mars is tough, but throughout history, humanity has never given up on reaching the stars. And remember, Mars is not just a planet. It may be the name of a second beginning. That's all from us today. See you in our next video. Please don't forget to subscribe to our channel, like our videos to help them reach more people, and leave your comments to share new video ideas or discuss your thoughts about this video. Until the next video, goodbye.